Bismillahirrahmanirrahim. Let's start question number 15 of exercise 4.5. To test its elasticity, a rubber ball is dropped into a 30-foot hollow tube that is calibrated so that the scientist can measure the height of each subsequent bounce. The scientist found that on each bounce, the ball rises to a height 2 by 5 of the height of the previous bounce. How far will the ball travel before it stops bouncing? So what do we have to find is that there is a hollow tube and its height is 30 foot, and a ball is dropped. Now we have to see that it drops, then it rises 2 by 5 of the height, then it drops, then it rises, and we have to see how many times it drops and drops and drops again and again to reach a point where it is still at the bottom. Okay, so for this we know that n is equals to infinity because it bounces so many times that we cannot count, and then at last it reaches a point of stillness and it stops. So the first height is 30 foot because it's dropped from the top till the bottom. So a1 is equals to 30 feet. Then r is equals to 2 by 5. Okay, now we are going to use this formula. S infinity is equals to a1 by 1 minus r. It is equals to a1 is 30 by 1 minus 2 by 5. It is equals to 30 divided by, let's take LCM, 5, and then 5 minus 2. It is equals to 30 multiplied by, take the reciprocal, 5 will go in the numerator's place, and 5 minus 2 is 3, will go in the denominator's place. 3 tens are 30 and 10 fives are 50. So it travels 50 feet before it stops bouncing. Okay. Question number 16 is, a hot air balloon rises 80 feet in the first minute of flight. If in each succeeding minute the balloon rises only 90% as far as in the previous minute, what will be its maximum altitude if it is allowed to rise without limit? Without limit means n equals to infinity. Okay, because there is no limit of time. Okay, so n equals infinity. In the first minute of flight, it rises 80 feet. And in each succeeding minute, the balloon rises only 90% as far as the previous minute. So r is equals to 90%, which is equals to 90 by 100, and it is 0.9. Okay. What will be its maximum altitude if it is allowed to rise without limit? So maximum altitude, we have to find the sum of infinity, which is equals to a1 by 1 minus r. It is equals to 80 by 1 minus 0.9, and this is equal to 800. So it is able to rise 800 feet if it is allowed to rise without any limit. And this was the last question of exercise 4.5. Thank you so much.